problems that you're going to see on tomorrow's quiz on graphing radical and exponential functions. My first problem here is to graph a square root function. So what I want to do first is graph the parent function. Now the parent function is not going to have the +3 or the -3 associated with it. It's going to be y equals 3 times the square root of x. Now with the square root function, you want to use just 3 points with 0, 1, and 4 for x in your table of values. So then I take each of those points and I substitute them into the parent function for x, and I simplify. So here I'm going to get 3 times the square root of 0. It's going to give me 0 for y. Then when I take 1 and put it in, I'm going to get 3 times square root of 1, which is just 3 times 1, or 3. And when I put in 4, I get 3 times the square root of 4, or 2. Square root of 4 is 2, so I get 6 for y. So now let me graph those 3 points. And 4, 6. Just like that. Connect the dots with an arc shape that starts at the origin. And now I need to decide what the shift is going to be. So if I add 3 to both sides of the equation, I get y plus 3 equals 3 times the square root of x plus 3. So a shift of +3 for x means that I'm going to shift the parent function 3 to the left. And a shift of 3 up, or +3 for y, means I'm going to shift the parent function 3 down to draw the shifted function. So now that I have directions, I go to each point and I move it as my directions indicate. So the first one I'm going to move 1, 2, 3, then down 3. Then point 1, 3. It's going to go 1, 2, 3, and then down 3. And then lastly 4, 6. So it looks like I was a little bit off when I was drawing that. Should be there. I'm going to go over 3 and the left 3 and down 3 once again. And I get a point that's actually going to be on both graphs, which is okay. Sometimes that happens. And lastly, I'm going to connect the dots with an arc. So blue is the parent, or I'm sorry, the shifted function, and red is the parent function. And then as far as the domain and range of the shifted function, well, I think you can see that the only x values I can use to get a result for y are where x is greater than -3, so that's the domain. So domain is where x greater than or equal to -3. And then the range, the only y values that occur on the function are where y is greater than -3. So my range is going to be y greater than or equal to -3. And I'm all set. Alright, the first few words tonight in the secret sentence are Mr. Hayden's forefather, John Hayden. Alright, moving on, next problem. Okay, now I'm asked to graph a cube root function. So let me zoom in a little bit so we can have a little more space. Okay, so I have y equals 4 times the cube root of x minus 4 plus 1. So once again, the first step is to graph the parent function. And for this cube root function, my parent is going to look like that. It's not going to have minus or plus 1. So now I'm going to draw my table of values. And for cube functions, we use point -8, -1, 0, 1, and 8. When I substitute each of those points in for the variable and simplify, I get the following results. I get it's going to actually give me -8 as well. It's going to give me -4. When I put 0 in, I'm going to end up with 0. When I put 1 in, I end up with 4. And I put 8 in, I end up with 8. Alright, so I'm going to graph the points. So -8, -8, let's see, -1, -4, 0, 0, 1, 4, and 8, 8. Okay, so I'm going to connect those dots with an S shape. Cube root functions are always S shapes. They go through, or at least the parent will always go through the origin. if I can draw a line here. Okay, something like that. Now I just need to decide what my shift is going to be. So if I move the 1 over to the left, I get y minus 1 equals 4 times the cube root of x minus 4. So my shift for the x comes from the negative 4, and that means 4 to the right. And my shift for y is negative 1, that means 1 up. So I take each point then and go 4 to the right and 1 up. And then the last point up here on the corner is going to kind of go off the graph a little bit. Okay, so now I have something that looks like that. And that's the shifted function. And the purple is the parent function. Let's see if I can find the purple again. And the domain and range of the shifted function would be all real numbers for both. Cube root functions always have a domain and range of all real numbers. There are no restrictions on what x or y can be. So domain, all real numbers, and the range is all real numbers. Okay, the next few words in tonight's secret sentence are settled in Braintree, Massachusetts. Alright, and I'm going to do one more problem here, and this is an exponential function. But I use a similar plan of attack to graph this as I do the square root and cube root functions. So my first step is I need to graph the parent function. So the parent function of this one right here is going to be y equals 2 times 3 to the x power. It's not going to have the minus 1 or the minus 1. And now I'm going to pick, I'm going to use the following values for x. And you're going to want to have a calculator on hand to do these computations because it makes it a little bit easier. And I'm also going to use decimals when I would ordinarily run into fractions. Okay, so the first thing I'm going to need to do is put negative 4 in for x in the parent function and then simplify. So that's going to give me 2 times 3 to the negative 4th power. So let me, well, let me use my other calculator while that one's still loading. Oh, maybe it's coming up right now. Yeah, there we go. Okay, so I'm going to do 4 times 3. Oops, let me see. Maybe it was 2 times 3 to the negative 4th power. So let me 2 times 3, exponent key, negative 4 power. That gives me 2 over 81. And let's see if I can do that as a decimal. I'm not quite sure why it's giving it to me as a fraction. Let me just do 2 divided by 81. Oh, not very helpful. Alright, let me use one of my other calculators. So 2 divided by 81, that gives me 0.024. So here I'm going to have 0.024. Then when I put negative 2 in, I'm going to end up with 2, let's see, it's going to end up being 2 ninths, which is 0.222. Let me just make sure I did that first one right. Yeah, I did. 0.024. This is 0.22. And when I put 0 in, I'm going to get 2. When I put 2 in, I'm going to get 9 times 2, or 18. And when I put 4 in, I'm going to get 162. Alright, so let me graph those points. So negative 4.024 is something like that. Negative 2.22 and 0.2. 2 is going to shoot up to 18. And then 4 is so far off the graph that I'm not even going to attempt to draw it. So let me then connect the dots with a bow shape. Right? And now I need to do my shift. So the shift, if I move this one over to the left, I get y plus 1 equals 2 times 3 to the x minus 1. So the left-right shift is minus 1. So that means 1 to the right. And the up-down shift is plus 1. That's 1 down. So I have 1 to the right and 1 down. So I go to each point and I go 1 to the right and 1 down. 1 to the right and 1 down. 1 to the right, 1 down, and 1 to the right and 1 down. And I connect the dots with a big bow shape. And I get something that looks like that. So that's the shifted function. And it has a domain of all real numbers. And it has a range of y, wherever y is greater than or equal to negative 1, because that's the smallest value that the function will take on. And I'm all set. I didn't, let me label the parent function. And the last few words tonight's sentence are in 1631. Alright, hope you found this helpful, that somebody watched it. And as promised, I will show you a couple of my cats. There's one right there. And there's one over there laying in front of the TV waiting for me to finish my screencast. So I can pet him. Alright, have a good night. Cheers.